Well, good afternoon, everybody. We're just waiting for all the participants to join. So just bear with us for a few moments until we hit the maximum number of participants. Okay, good afternoon, everybody, and welcome to the second of today's webinars from Smart Vision Europe. My name's Jarlath Quinn, and in this session, we're looking at data cleaning and all the issues associated with cleaning data and dealing with problems of data in IBM SPSS statistics. Just a few housekeeping points at the start of these sessions, particularly if you haven't joined them before. We do record the sessions, so you'll be able to listen to it again afterwards, particularly if we're going over things that you think that might be relevant. I might want to look at that again. There is some slideware, not a huge amount, just to sort of introduce the various demonstrations. And we'll email out to you a copy of a link to download the slides. If you think it's particularly relevant for colleagues, then the best thing to do is just ask us, and we'll see if we can rearrange it, rerun it if they're unable to attend today. And with regard to asking questions, all the lines are muted. We ask people to use the chat panel. We may not actually answer the questions during the session. We do tend to get a lot of questions and email through to us after the session's ended, so we take our time to answer those thoroughly. So feel free to email us afterwards, and if we don't get around to answering you during the session, bear in mind we will answer you after the session's ended, so don't worry about that too much. With regard to who we are, we're Smart Vision Europe, and we're a premier accredited partner to IBM, as well as an organization called Predictive Solutions and Data Robot. And that means that we specialize in advanced analytics and big data technologies, data science, machine learning, all that sort of stuff. We also work with open source technologies such as R, Python, and Spark. And we're made up of a team of individuals who have a long history working with analytical software, and especially with SPSS. My own career of SPSS started in the mid-90s, mid-1995. And prior to that, I was an analyst using the software for a long time. So we're pretty used to working with it. We're pretty used to answering technical questions around it and providing consultancy and help, etc., etc. We have pretty deep experience of applying analytics and statistical analysis and reporting and machine learning, all those things across many different applications in many different sectors. So things like machine learning applied to things like predictive maintenance for water utilities and telecommunications organizations, basket analysis and promotion analysis for retailers, insurance risk analysis, financial risk, financial marketing, gaming and media, loads and loads of different applications going back over nearly 30 years. What we're going to be talking about today is very relevant to that, almost to any tool that you're using, whether it be SPSS or SAS or Tableau or SQL or Data Robot or any of these tools that you want to use. Data cleaning and how to deal with data that pretty much messes up your analysis in some way or changes the context of your analysis in a way that you don't want is a universal issue. So, as I say, data cleaning and getting our data in shape is a universal problem for anybody who works with data. And errors and irrelevancies can, of course, occur in data due to lots of different examples. I mean, lots of different reasons. So things like misplaced keystrokes, somebody literally just typing in the wrong keystroke, that can lead to a category being introduced into a field, or a value being introduced into a field that does not make sense. Other thing that's very common is inconsistencies in recording information between not just different data entry operators, but sometimes different systems over time when they're amalgamated. So you'll see that you could see something like a city name like London being spelled, uppercase, lowercase, or in a mixed case. Or you may see a new value being introduced to represent a new product, or a new category of individual, which leads to issues when it comes to analyzing, because you don't know who that category is or what that category is about. You get information that's collected on non-applicable events or subjects. I mean, basically, you get a lot of values which are really not that of interest to you, or which indicate that particular service or particular product or that particular event didn't apply to that individual. And you may need to actually tell the system that this is a non-applicable value. It's a value that shouldn't be included in the normal analyses. You get things like mismatches between database tables. Often when you go to match data from, say, two different locations, or from two different subject areas, such as transactional data and customer data, you'll find that you get, mismatches. You get people where you have information about who they are, but you know nothing about their transactions, or you get people where you know all about their transactions, but you know nothing about who they are. And you get these mismatches that occur and duplications that can occur. And differences in how systems encode or represent data, such as data time fields. This is the big issue with a lot of tools these days, is that the way in which date time fields are represented tends to vary quite a lot from one system to the next. So you see an awful lot of investment in analytical systems these days, which try to automatically recognize date and time fields, because it is such a headache for researchers and analysts. And it's hardly surprising. You think something like Excel, I think, encodes a date field from a time point, from a reference time point, like the 1st of the 1st, 1900, whereas a system like SAS would encode it from the 1st of the 1st, 1960, and a system like SPSS encodes date fields from, I think it's something like the 14th of October 1582, something like that. It's the introduction of Gregorian time. So the way in which one system sees a date is not necessarily the way in which another system sees a date. And then you have slashes and dashes, and whether a month is represented as a name like November, or whether it's represented as numbers. And then you have issues of whether or not it's in US time format or European time format, where the month is second as opposed to first, and so on. There's a lot of potential there for things to get messed up. So we'll be looking at how we deal with those sorts of issues and other issues as well. So typical tasks and data cleaning, things that we should be expecting to do, is things like identifying records or fields that just have a lot of missing values. You could have a record, an individual record, where you know somebody's name, you know the date of birth. You really don't know much else about them. They're just missing all that data. You might want to ask yourself whether or not you actually want to retain that record, given that they're bringing so little to the analysis. Alternatively, you'll have fields which just have a vast amount of missing values, because the values that they do encode, the valid values, only apply to a very small minority of the data set. Sometimes you get a high degree of variability. That's not necessarily a problem, but if it's something like a product code, and you've got 16,000 different product codes, and you're not really analyzing that product code per se, you're not particularly interested in it, or like the same way if a postcode, if you're not really using a postcode, you might say to yourself, well, the fact that it's so variable means that I'm not really that interested in it, because it's too hard for me to summarize it in some way. Or conversely, too little variability. You do get situations, I commonly get situations where I read data and you'll get fields that only have one value in them. And so if they've only got one value in them, they're literally useless. You might as well just drop them from that data set at that point. And you have issues of correcting values that are out of range. So people with strange ages, like minus numbers, or impossible ages like 199, that type of thing, very common. Duplicate records, and you have something's been entered twice, can happen a lot with merging of data. And if it's important for the purposes of the analysis that each individual row represents a different entity, a different person, a unique event, or a unique place or something like that, then then duplicate records can be a problem, and identifying them and removing them may be one of the tasks. Ensuring that variables are correctly formatted, removing decimal places from age. That's pretty minor, but as we will see, there are times when it just makes things a lot easier if the variable is correctly formatted. It means that you don't have to change the formatting after you've done the analysis because it's been inappropriately formatted to begin with. And we'll be looking at those examples right away at the start, checking that all the values and combinations of variables do not contradict each other. So these are situations where the values themselves are perfectly legitimate. There's nothing wrong with them. They're not extreme. They're not unusual, but combinations of them are unusual. So you have somebody who's a car driver and, they're 14 years old or something like that. They've got a driving license and they're 14 years old. One value contradicts the other. A final task might be creating syntax to correct data issues automatically. So if you are reading data on a regular basis, even if it's a slightly different data set each time, but the field names are the same, you might create a syntax job which will automatically clean the data, or at least automatically flag up where the errors are and the issues are in the data. And as we will see, there are some procedures in SPSS statistics that will help you kind of do that stuff automatically anyway. We have what's called data validation, which we'll come to in a moment. Okay, there are two broad classes of errors in data. And we're going to deal with the one on the left first of all. Data formatting issues can be caused by how the data was stored in other systems. So when the data is read in, this is particularly true, of course, when you're reading the data from Excel, from a CSV file, from a survey platform like SurveyMonkey, or you're reading it from a database extract or something like that. You may find that the way in which those systems encode their data isn't the way in which SPSS would necessarily do it, and it can cause issues. So knowing how to format the data to maximize or optimize your analysis can be an issue, and that's one of the first things we're going to deal with. And then the second thing is problems with the data itself, not necessarily problems with the formatting of the fields. Problems with the data itself, actual errors, genuine errors that have occurred, values that make no sense, inconsistencies, duplicate records, illogical relationships, irrelevant values, irrelevant records, or irrelevant variables can all be an issue. And really what you're trying to do is get down to a data set that you've thoroughly cleaned, that you've prepared, you've got rid of all the irrelevant and spurious values and records within that data set, so that then you can begin the next process of analyzing the data properly. Okay, so let's look at the first one, which is sort of data formatting problems. I've got a little data set here, and if you joined us on the previous webinar, you'll know that we use this data set regularly because it's got a nice mix of variables and fields in it, and it tells a decent story. That's the employee data set. And I've just introduced a lot of errors into this data set, or problems with it, which might mess up our analyses. So one of the first things is that you can see that you got a variable here called var001, which is just a weird name for a variable. That can happen very easily in SPSS, particularly when you're importing data from another format or another third-party storage system, whether it be another analytical system or some sort of platform, some sort of database platform. You may easily end up with many fields called things like var001, var002, var003, etc., even though those fields are not called that in the original data source. So how does that happen? Well, it's because SPSS has rules around field names. And one of the rules is that the field name has to begin with a letter. And the field name shouldn't contain special characters like asterisks or dashes or spaces or quotes and things like that. It'll let you get away with an underscore. You can use an underscore, and sometimes you can use things like hashes and stuff like that, but those tend to be special characters. Hashes tend to be special characters, mostly underscores, but most you get away with. In SPSS, it has to begin with a letter. You can have numbers in there, but it has to begin with a letter. So if you had if you had a field in a third-party system and it was called 01 space product, something like that, 01 product, and you read that in the SPSS, you wouldn't be surprised to find that it renames it to var 001 like this. So the first thing is that you can change that. So you can double click on it. And it's a good idea if you want to get into the habit of playing around with the data and formatting the data, just to double click on the thing that you want to change. You can double click on it. And you can change it to this. You can call it job cat. Just do it manually. You should also bear in mind that much of the things I'm talking about here can be done through syntax. So syntax is code. So if you wanted to do this automatically and you saw if it was always renaming it the var 001, you'll find that you actually have a little command here, which is like rename variables. I think it's rename variables or rename variable. And I think it's something like, let's see, rename variable. I'm going to call this, let's say we want to call it job cat equals, I don't know, job role, something like that. Stop. Let's see if that actually works. If you want to check your syntax, I'm not entirely sure about this one. Let's say I think it's something like that. I'm going to check. Let's see if I want to check that syntax. I can click on this little syntax help button, and that just loads and takes me into the SPSS help system for that syntax, for that particular command. And you can see there it is. It's rename variables. That's what it is. Rename variables, var name equals new name. So it's just useful if you want to do it. Same thing if you were like dealing with missing values or something like that. You might say, okay, I want to, what's the syntax for missing values? Just click, open up a syntax window, type in missing values, something like that, and then just check that little button there to take you to syntax help. So rename variables. Let's see if this works. I want to run that and then run it. You can see it's just changed it here to job role. Okay, so syntax is a useful way to do this sort of thing. Are you able to write syntax and write a command to identify and remove a duplicate? Yes, you are. You're able to reduce a duplicate. We're going to come to duplicates later on. There's a command called identify duplicates. And you can't have duplicate variable names, of course. You can't have duplicate variables with the same name because it wouldn't allow that. If I had another one here called job role, it would call it job role too. So I just go back and I'm just going to change this to job cat. There we go. So that's a really simple one to begin with. What else have we got? Well, we've got some interesting little issues here, but you can see if I look at this variable here, sal begin, this looks fine. This is people's beginning salary. If I right click on that and hit descriptive statistics, you can see it gives me some nice simple descriptive statistics here. It shows me the mean value $17,000 and the median $15,000. It's been really sensible. It's just and what the minimum and maximum beginning salary is. But look at the field next to it, which is salary. It looks the same, except it's got a different symbol associated with it. Okay, so this is also a formatting issue. This is an issue with what's called levels of measurement. So if I go to click descriptive statistics here, this one, you can see that it just gives me this sort of nonsense. It just gives me this really, really long frequency table, even though it's measured in exactly the same units as the previous one. And that's because it's been formatted wrong. It's been changed into a nominal field. That's very common when you're reading data in. SPSS doesn't know what format it's supposed to be in, so what the level of measurement should be. This is changed by, again, double click on the header. It's not this thing here, not type. If you go along to the end, you can see here where it says measure. Okay. If I change that to scale, so it's like the other variable, come back down. Now we've changed that. Okay. And now it's been formatted. Why would that make an issue? Well, you'd be surprised because certain procedures, they just won't even let you see these nominal fields. If you go into like a dialog box or something like that, and you're going to ask something, sometimes you won't literally see these ones that have these nominal categories associated with them. So you may be saying, where is that field? Why is that field not appearing in a dialog box? And it's because it's been formatted incorrectly. So it's not just about right-clicking on it and asking for summary statistics. It's correct to identify it as a scale field because it's not a series of categories. It's a series of individual individual values, if you like. Okay, so one of the things that happens is, of course, as we're cleaning our data, we tend to discover issues as we're going along. So I do a lot of this. I do a lot of right clicking and just checking stuff as I'm going along. If I think it looks a bit odd, if I hit descriptive statistics here in this one, this is the variable called age. And right away, I'm looking at the minimums and maximums here, and I'm seeing the minimum is -9 and the maximum 62. So that's kind of strange. Why would that happen? Well, because -9 is a non-applicable value. It's a value that's been, let's say it's been imported from another system, and if it is decided that -9 is what we're going to do to represent when we don't know somebody's age. So again, there's syntax that will do this. The syntax that will apply a missing value in the same way that the syntax that will change the level of measurement. If I want to change it manually, I can just double click on it. And all I need to do is tell it that -9 doesn't mean that somebody's aged -9 years. It just means that it's a missing value. And we're going to set it as a missing value. You might just do that with any value. It didn't make sense. You might just sort of say, look, that doesn't make any sense. So I'm going to nominally set it as a missing value, if you like. So what happens now when I right click on this and hit descriptive statistics? Well, now it says the minimum age is 20 and the maximum 60. And look what it's done. It's the mean's gone from 34.45, and the median seems from 29 to 34.73. The median's still 29. There's only 6 missing cases there. That's 6 were -9. Actually, that's actually, there were 3 missing cases already. That means that there were 3 records that just had what we call system missing values and just nulls in them, just nulls. And we've added an additional 3 by changing -9 to a missing value. So that means that there must have been 3 occurrences of the -9. And now we've got rid of that. And the only thing that's left are legitimate values, which run from 20 to 62. So simply, again, you could apply some syntax that's simply doing that by identifying that a value is out of range and deciding that that value should be a missing value will mean that it no longer has an effect upon things like percentages and means and medians and that sort of stuff. We've basically told the system to ignore that. Okay, what about this? There's another variable here. We've got a variable here called job time, and I can see just glancing at it right away that there's an issue with it. This should be like this variable. This variable here is previous experience in months, and you can see it's a scale variable. This one here is job time. That's months since hire, and right away we can see that first of all it's a nominal field because it's got these little circles. It's just to show you this. So you can see it's got these little circles associated with it. Where is it? Months since hire. So it's got these little circles associated with nominal. Generally speaking, we can have nominal, meaning that they've got these little circles, meaning that they are categories that have no order to them. There's no natural order to them, like region. There's no natural order, or color of car has no natural order to them, or ethnicity has no natural order to it. Ordinal tend to be rating scales or things which have an order, like low, medium, high, or even things like seasons, where there's an order to it. You have autumn, winter, spring, summer, that type of stuff. And scale tends to be numbers. Well, it thinks that this is a nominal field. Why does it think it's a nominal field? If I just double click on the header, it jumps back here. It's because it's seeing little X's appearing in the data. So these little X's have appeared in the data, and it says, I'm seeing letters. I'm seeing letters in this column here. I can't represent this as a true number if you want me to keep these X's, you want to keep these letters. So therefore, I will make it a nominal field with these little circles, and I'll put a little a next to it, the a indicating that it is a string, a character string variable. So although this says 97 and 98, it doesn't really see them as numbers. It sees them as characters like A, B, C, D, E, because it's trying to preserve the X in there. Now, if we don't care about the X, and we say, actually, we want to return this to a number, there's different ways in which you can do this. You could just double click on it and say, look, I'm going to force this to be a numeric field. I'm changing it to a number. Click continue, click OK. And in doing so, you can see it's just kept the numbers, and the X's are now turned into what are called system missing values. These are null values if you want it. So we can do that, and it's an easy thing to do that. In fact, if we wanted to, for whatever reason, say, let's just check this and make sure it makes sense. Descriptive statistics are. The next thing is, you can see again, it's producing a table for me. There's something I forgot to do. I forgot to double click on it, of course, and tell it that, okay, you're no longer a string and you're no longer a nominal variable. You're actually a scale variable. So when I right click on it and do descriptive statistics, it says, oh, there you go. The mean is 81 months. And the minimum 63 months and the maximum's 98 months. And there are 5 missing occurrences, 5 occurrences where you're getting these little full stops. You could, if you wanted to, you could do something called use the series mean and replace these values using a series mean. Let's see if I can find that. Where is that? Prepare data for modeling, create time series, replace missing values. There it is. Sorry, it's hidden away down there. Replace missing values. So I could take something like job time here and say, okay, I'm going to create job time 2. It's a bit weak, but series mean would mean I'll just replace it for the average. If this was a sort of time series where these were values over time, and there was an order to them, then you can see that you can say mean of nearby points. So you can say kind of what's called interpolation. You kind of say, no, just take the average of the nearby points. So I could do this. I could say, look, just use the series mean, click OK, and just stick that in there and create a new field called job time 2. And it says, okay, we'll go off here, click, job time 1, and it just replaces it with the series mean, which is 81 here. So there are things you can do if you have loads of missing values, and you say, look, I just need to plug that in. I just need to replace it with something else that makes sense to me. Okay, let's look at another field here. So we talked about the issues around date of birth, around date fields. And I've tried to create one here, which is kind of messy or a problem. You can see that this also has a little A symbol. A stands for alphanumeric, meaning that it's a string field. And because it's a string field, it can't represent it as a scale field. It has to default to a nominal field type. So we have date of birth here. If I right click on that, it's not going to give me the average date of birth. It doesn't even know it's a date. It just sees it as a series of categories. Now, there are different things you can do here. It turns out, I'm actually, tell you what I'm going to do. I'm going to, just for safety purposes, I'm going to insert a new variable here. So I'm just going to say insert variable. You can see any new variables is given the default var001. And what am I going to do? I'm going to make a copy of this field. Let me see if I can copy this in there. Copy, paste that in there. Let's see if that works. Okay, because of var001 now, but it changes it to string. I'm just call it DOB2, sorry, for illustration purposes. Sometimes you can get away with just double clicking on these and just double clicking on them and saying, right, I'm going to change that from a string to a date. And it says, okay, well, how do you want it represented? What's the format? Sometimes you can get away with it. And it turns out in this case, even though this has the names of the months in there and they're abbreviated names and it has slashes, it turns out I may be able to get away with doing this just by going to date and saying, okay, well, I'll have that with just hyphens in between it. Click OK. Did it work? Yes, it did. And if it didn't work, you'd be able to tell right away because these would all be absolutely just blanks like that. I wouldn't do anything with it. That doesn't always work for every single date field. There are going to be times when, they're going to be inconsistent, where there's going to be upper and lower cases, where there's going to be extra spaces, etc., associated with that. In which case, you can always try to do what I did and just create a duplicate of it, copy it, and then just insert, hit a blank, insert a variable in here, and then just paste it in. Then just try and change it and see if it works. But if that doesn't work, then try going to transform date and time wizard. So date and time wizard is really good for dealing with date and time fields. And you see that date and time wizard here is just a way for a little box of tricks to help you deal with the fact that, You might have a number, you might have the date of time imported from another system, but it's actually come in as separate fields. So sometimes you get the day, the month, and the year as separate fields. And you can combine them together using this create date or time variable from variables holding parts of date or time. And then you just tell it which one is the year, which one is the month, which one is the day. And, you know, in the same sense, you might have time, you might, which one's the hour, which one's a minute, which one's second, if these are all separate fields, and it will just combine them all together for you. So that's a useful one to know about. But if you get a really awkward string field that says create date or time variable from string containing date or time variable, you could do what we've done here and just click on DOB, and it says, okay, I'm just going to scan the first few values here. Can you tell me which one of these this matches? And you could say, yeah, I do, and you go DOB2. Sorry. Tell it what output format you want. Date of birth. So go back here, check this. Is that the closest one we have to it? Kind of, yeah. You might get away with doing it this way. Date of birth. Sorry, let me just give it a label again. And then hit finish. Jump along to the end. Date of birth. Did I overwrite it? Let's have a look. I'll have to do it again, I'm afraid. Let's try it again. Let's go for pattern. Day, month, year. Could be. I need to find the right pattern for it. Let's just try this. We've got I'm just going DOB2 and hit finish. So, it's giving me I think it's giving me an error. It didn't like it. Okay, so it's actually one of these. It has done it here. It's just complained, but it's called DOB2, but it has found issues somewhere down there with probably one of those values. Anyway, the point is that you can try double clicking on it, creating another version of that variable by double clicking and maybe jumping to that variable and changing it to a date field. The only danger of that is you're overwriting it. So I tend to right click and go insert variable, and then give that a name, and then copy and paste it, and then work on the copied version of it. Okay, so this is most of the issues we're dealing with here are actual issues around the formatting of the variables. So we haven't actually done that many problems with the actual data itself. That's kind of been the theme. Let me just change this date of birth here to a date of birth field. There we go. So date of birth. It hasn't got an issue with the actual data itself, but I can see from glancing at it, there's some here which are kind of suspicious. If I go to the data menu here, we can come to validation. So this zone that we're in now is problems with the data itself. We're looking at that section here. And you'll find that this functionality is standard now with SPSS. It used to be an additional module. It's now standard. And what you get with this additional functionality is the ability to identify duplicate cases. That will identify duplicate cases. The ability to identify unusual cases is also part of that family of techniques. Unusual meaning anomaly detection, ones which kind of stick out. It's used a lot in fraud analysis. And then we have what we're going to talk about, which is validation here. And you can see here it says load predefined rules, define rules. If you just click on validate data, it'll open up this fairly friendly little dialog box here for you. And it says, are you able to write duplicate? You might be coming into this, but how do we change? You might be coming onto this, but how do we change those to, for example, -9, so to show it as a value for missing data? Somebody had asked this. Example minus. Okay, so if you want to change any value, like something that was like -9 to missing, You double click on here, and you go into missing here, and you say -9 indicates it's missing. And in fact, if you wanted to tell it explicitly that -9 is missing or unknown, you could add a little label to that. That's just a label to explain what that is. You can see, and it just adds a label there, unknown, say. So you can see it's a label, switching on and off. And then if I want to go back to what it was before, I just delete it. Okay, we're talking about validating data here. We're going to validation, validate data. And it says, okay, have you got a case identifier variable? Have you got some sort of ID? I do. I've got one called employee code ID. And what do you want me to analyze and check over? Well, I want you to check over everything else. I'm going to leave date of birth out of it because we dealt with that. And then we can walk through these different little tabs here. So the first thing we've got is basic checks. What's basic checks doing? Well, it says flag variables that fail any of the following checks. And it's basically a set of predefined little rules. So it says, you know, maximum percentage of missing values. If you've got a variable that has that's more 70% or more of it is made up of missing data, I will flag it for you. And you might think in a data set like this, it's pretty obvious. You'd be able to identify them. But look, obviously, if you have hundreds of fields, which is not uncommon, you know, this is a very fast way to do that. Where the maximum percentages of cases are in a single category. If you've got a variable where 95% of the cases all have the same category, it means that, you know, it's very heavily dominant. It's not very variable, you know, so you might want to identify that. Maximum percentage of categories with a count of 1. So for 90% of your data, the categories are all so unique that they only occur once. That would mean that you're probably dealing with something like a product code, something like that. Are you really interested in that sort of stuff? It'll flag it up because it's going to use, again, something which has very little variation in it, minimum coefficient of variation, minimum standard deviation. If it's 0, it means it's got no variation. And then flag incomplete IDs and flag duplicate IDs. So it will do that. It will even flag empty cases where the entire row is empty except for the ID field. So again, that can happen. So you've got cases where the entire row is empty apart from the ID field. So these are just the basic checks that it runs automatically. And then we have what we call single variable rules. So single variable rules are, you know, this is kind of defined by the fact that we can see a little overview of the data here. So we can see a little overview of the data here. And one of the things I'm noticing right away here is that the variable gender here, it looks like this. It says minimum is blank, maximum is M. The variable the variable city here just seems to have one value here of Chicago in it. Education goes from 8 to 115. So looking at minimums and maximums can be, you know, really useful. Employment appears to have 4 employment categories, fine. But if I wanted to get rid of one of those employment categories, it might be useful to know about. Salary looks okay. Months look okay. Previous experience goes from 0. Minority only has 2 values, 0 and 1. And age runs from 20 to 62. So it looks all right. We can limit the number of cases that are scanned. So we can say, okay, just limit it to the first 50,000. In this case, we've only got like, I don't know, about 470 records, something like that. So we don't have to worry about too much, but you can rescan it. And then we have something called cross variable rules. This is something I realized in the previous, from doing the previous session on this, is that I had already created a cross variable rule. I'll come to that in a second. It saves the rule with the data set. It's interesting that I say, actually, I had created a little rule as an example, and it saved it with the data set. So I'll switch it off now. We'll come back to it later on. And then we have the output in the reports. So if I just click OK of this, and we'll just run with the, you know, the sort of the kind of basic settings. What's it doing? Well, it says here we have validate data. Here's our section here, and it says, okay, you've got a variable here where the cases are constant. More than 95% of the cases all have the same values, and that's the variable city. What's that variable? Let's right click on it. Let's look at it. Okay, so it's got 3 blank and 476 records where it just says Chicago. So that's not very useful to me. So I'm gonna delete that one because it's an invariant variable. What else is it saying? It's saying you've got a duplicate identifier. It says you've got two duplicates, and it's cases with the identifiers 20 and 21, and the identifier code, the same value that they have is value 20, that means that they are ID 20. So if I go down here to 20, it's basically saying, look, there you have. There's 20 and 20 and they're duplicates. Interestingly enough, as we'll come to later on, the variable gender here has been encoded slightly differently. Lowercase f for female, uppercase f for female as well. So there's a little bit of inconsistency there. What might I do with that? Well, I might decide actually, because they're effectively duplicates, I'm just going to, get rid of one of them. So I could just highlight that and say clear. That's one way to do with that. Another thing you can do is if I undo that, let me just Control Z undo that. You should be aware that that might work in circumstances when you only have one or two duplicates. But what if you've got loads of them? In that case, you could click on the save button here and say save duplicate ID group like that. Let me just say if I click OK, run the thing again. And now we've got an extra field here. See, it says duplicate ID group, say. And I could actually find anything that's got an incomplete ID or anything that's got a duplicate ID in that series of records. There it is, 1 and 1. And I could sort them in order. So anything that has a 1 indicates that it's got a twin, basically. That's all it says. So I've got a duplicate here. So it's just a faster way to identify it. And you could use things like select cases, something like that, to filter out or identify a duplicate. So here it's number 20. So I'm just going to clear that. And I'm also going to get rid of these new variables I've created here, which show incomplete IDs and duplicate group. Okay, let's go back to the output. What else was in the output? Okay, it says identify employee case check. So duplicate IDs, duplicates. This table displays cases for which variables except the identifier rule of variable are missing or blank. So it's saying you've got a case here called 76, case number 80, and case number 83, which have the following employee code 741, 791, and 791. And they've got ID codes, but they've got nothing else. So if we just go back down, let's have a look. What was it called again? It was excuse me. That it was, just get the numbers. 7680. Let's just scroll along here quickly. Yeah, so there we can see them. Let's say we've got this one here, 75, 79. So these got different codes, okay? They've got different codes, but you can see that although they've got ID values, they've actually got nothing else in there. So it's showing ID number 741. You've got a value for that, ID number 771 and ID value 791. These guys are all blank. So again, you could use your incomplete ID. If I went here and went to validate data and said, look, save incomplete ID as a variable for me. Sorry, not incomplete ID, but actually blank values apart from the ID. I could just manually highlight these guys and then delete them if I wanted to. Just hit delete. So I'm going to hit Control Clear, just clear them out. So I'm cleaning up the data as I'm going along. What else have we got? We have it's kind of finished at that point. Let's see, ID it says incomplete ID, case number 478 is an incomplete ID. Why is that? Okay, so it's looking at the ID number. We'll go down to case number 478 down here. It's actually this one, case number. The case numbers are changing because we're deleting fields. We're deleting records. So of course, what was 478 is now 475. And it's basically saying, look, you don't have an ID for this guy. Do you want to sign, or this lady here, do you want to sign one? Well, I might make one up. So I might say, okay, show me the minimum maximum of these. So it goes from 1 to 474. So I'll just give that one case number 475, I guess, 475, and I'll give them an ID at that stage. So that's an incomplete ID that's been fired there. Every time I'm going back here, if I go back to validate data I'm just going to hit reset here. Let's go back. Let's see what else we can do. Let's send everybody else across again. So into this, apart from date of birth. What else are we seeing? So we're seeing all this sort of stuff here. What single variable rules here? Well, there are various sort of single variable rules one could have. You could say minimums and maximums. So you could say, look, education, running from 8 to 115, that seems a bit weird. That just seems a bit strange. So I could define a rule, and I could say I'm going to create a rule called, EDUC or something like that. EDUC rule, education rule, and say the minimum should be 0, and the maximum should be, I don't know, say 24 years, something like that. Let's say 20. Let's put 26 years, just be on the safe side. Allow non-integer values within the range. That means so you can have decimal places. Well, no, I'm not going to allow that. Allow user missing values. Yeah, allow those in there. And what's the field type? It's a numeric field. I hit continue at that point. And there it is. And if I hit apply at that point, it should apply to the EDUC rule. You see, as I click off it, it's not applied, because you can apply the same rule to different fields. But as I click on the education, I can say that is my EDUC rule that I'm going to put in there. So I could put a little rule in there. I can see that gender has multiple categories in it, so I might have to deal with that in a second. And I can see also this cross variable rule, which keeps getting applied. I'll come to that in a second. Let's deal with, first of all, click OK here, and we'll just deal with the education category rule. See if that works. Click OK at that point. Okay, it says a case number employee code 147 has an issue with the employee code, so we'd go to 147. Sorry, with the education value. And he's got 115 years education. Now, if you don't know, if you literally have no idea what that person's education is, you can either replace it with a mean, or you can just hit delete and just take it out. And we don't know on this person's. I'm just going to delete it. Now, what about this variable here, gender? I click descriptive statistics. It's very inconsistent. We've got F, lowercase, uppercase F, lowercase m, uppercase m. A fast way to deal with that is just to convert everything to one case, or lowercase or uppercase. So I'm going to create a new field. I'm going to use the compute variable to do this. This is a fast way to do this. You could use recode as well. So I'm going to use compute here, and I'm going to create a variable here called gender2. And what I'm going to do is just take the function. I'm going to take a function here called upcase. I could actually make it lowercase. I think I might make it lowercase, just for aesthetic purposes. Lowercase, that should be it, and then hit. I think that should do it. Put gender in there. I click OK. Let's see if that works. Oh, it's telling me that you need to make this a string field. That's all it's saying. You need to make this a string field and give it width. Well, it's a width of 8. It actually doesn't need a width of 8. It needs a width of like 1. I click OK. Let's see. Okay, so they're all F and M's now, and I could just click this and just, if it isn't that big a data set, I can just drag that along there. I could delete the original one, which with its mix of uppercase and lower cases. I could rename this one now to just gender, and I could give it the label gender, employee gender or something like that, or employee sex or something like that. And then I could assign some nice value labels to M and F. So I could say M male and F female. Click OK at that point. Right click on it now and hit descriptive statistics. There we can see 45.7% female, 54.3% male. That one's been cleaned up. Okay. I kept talking about trying to switch off this validate rule that keeps coming up, this cross variable rule. You'll see it here. Let me switch that off. This cross variable rule is one where you both variables have perfectly legitimate values, but where the relationship between them is problematic. And this is where cross variable rule is defined. If I show you what it's actually doing. In this example, we go to define rules. It's just this little bit here. It's a very, very simple little expression, and it's basically saying, though it's a bit spurious, it's saying that somebody's if somebody's salary is less than their beginning salary, then that should create a flag that should evaluate to 1 for an invalid case. So the rule expression is one which identifies a invalid situation. What we're saying here is that on no occasion should somebody's current salary be less than their beginning salary. Now, in reality, of course, that could happen, because of course people could get demoted, or they could go part-time, but let's assume that in this case it doesn't make sense. Or let's say it was a variable like age today and age when started. You shouldn't be younger today than when you started. So salary check here is a little rule that fires that. Now I click OK at that point. I could hit save. I've got incomplete. I've got validation rules. I could ask that to save that. I could also ask for a little report here. It says it's employee code 15. It says, so it's employee 15 out here. So let's just see if on the salary check here, if it comes up as well. There it is. It's case number 15, employee code 15. And this person's beginning salary is less than their current salary. So let's just say that we happen to know that's an error. And we change that to 23,000 rather than 27,000. So lots of different things we're going through there. We're going through lots of different examples. We're really using a mixture here of our own analysis, where we're noticing things in the variable and in the data set. But bear in mind that we have this really useful validate data procedure, which, apart from anything else, one of the most useful things about it is just the fact that it gives you this little sort of report here where you can just see the variables and see the minimums and maximums very quickly, and it'll flag up really basic checks, incomplete IDs, duplicate IDs, that sort of stuff, which will help at least point you in the right direction with regard to cleaning your data. Eventually you're going to get to the point whereby you hit save and you have a cleaned version of your file. If, by the way, just so we're finishing up here, if by the way you're using select cases, sometimes you might want to select out non-relevant cases. We go to select cases here. Just bear in mind, let's say I happen to know that there's another category, and there actually do have an employment category in here. Here we go. Let's say we've got an employment category here. If I just right click on this and show this, we've got 3 occurrences of intern. Okay. Let's say for whatever reason I wanted to get rid of those 3 records because they're not relevant for my analysis. If I went to data here, select cases, if condition is satisfied, I could say if jobcat is not equal to, and the code for intern is 4. It means select them if they're not 4s. And I could either delete everything, which is a bit, kind of extreme, or I could say copy out into a new data set. So I could create a new data set here called no interns and click OK. And then I'd get this. You can see it open here. It doesn't have a name for the file, but it has a little label for it called no interns. And if you do an analysis on that and ask it to do a right click or something like that, it'll give you a new employment category table, and you can see the interns have been removed from that. So again, another way for us to deal with missing data. What happens if you are to merge data that has had validation rules applied with data that has not had the same validation applied? It depends what you mean by that. So it's if you mean the validation rules are saved in the data set and data set 1, but they're not saved in data set 2. I think that when you merge the files, it creates a third data set, and we'll call it data set 3. And data set 3, I don't know if it will have the validation rules in it. I haven't tried it. The best way to do is to check it. If you needed to keep them, you'd probably be able to paste them as syntax and use them again. But I literally don't know. I've never tried that. If it creates a new data set, it may well, because it's not saved as part of that data set, it may well not carry those validation rules across. Okay, that takes us to the end of that tour through cleaning, data cleaning, and using the sort of standard procedures that we've talked about thus far, where we're manually clicking on stuff, we're double clicking on headers, changing them, we're changing the formatting, we're using the validation rules procedure. Just be aware that you can look at data cleaning with syntax here. So we have, I think, some syntax jobs that we could call up. I could potentially save everything I've done thus far as syntax. Let's see if I can find this one. Yeah, data cleaning syntax. Click open here. That gets the file employee for cleaning. Let's see if I can do this. Let's still run this file new data. So, and I'll just close down all the other data files that I could open at that point. Close that one as well. And I've got some output open, which I'm going to close as well. I'm just starting with a completely blank data set here. So what are we doing? We're doing pretty much everything we talked about in this webinar here, where we grab the data, rename the variables, change the level of measurement to scale, assign missing values to age of -9, etc., all the way down through that. We can just run the whole thing. So that's another way, if you think about, of you cleaning your data or saving your validation rules, if you like. You can actually do it through syntax as well. Okay, in the next session, we're going to be looking at significance testing. We do hope that you'll join us for that. In the meantime, there are some additional resources you might want to look at, such as looking at our SPSS FAQs, our video guides, our how-to topics. We've got information on our website, of course, about the SPSS software, and we've got a blog series on statistical testing and procedures. Thanks very much, and we look forward to you logging in again.